As I said, what emerged after the 30 Years' War was a movement away from religion as a foundation of critical thinking, and instead, what was replaced was a reliance more upon science and evidence obtained through the use of the human senses and analyzed by human reason. And no one epitomized this progression more than the man in the portrait to your right. He was born Mikolaj Kopernik. It's a familiar name, isn't it? But we know him better as Copernicus. His theory would set the world on end and challenge long held beliefs. It was not just Copernicus who held sway in this period. Various breakthroughs occurred in medicine and scientific experimentation, and the result of this was the pushing of magic and superstition to the periphery, although the magic and superstition did not go willingly to the periphery. Nicholas Copernicus was a Polish polymath. That is, he essentially knew everything there was to know in those days. Now, that's not really possible anymore, although we can say like people like Stephen Hawking, the late Stephen Hawking, and others. But still, the amount of knowledge of today compared to back then, simply, it's exponentially bigger. His book on the revolutions of the celestial spheres challenged the notion that all heavenly bodies revolved around the earth and instead posited the sun at the center of the universe. And we call this heliocentrism. Now, heliocentrism had actually been proposed by the Greek astronomer Aristarchus 1800 years earlier. But Aristotle and Ptolemy gainsaid his theories and pushed them back. Well, Copernicus now brings back Aristarchus's theories, although he himself was not familiar with Aristarchus, and he overturns the theories of Ptolemy and Aristotle. He not only proposed this theory, he also made tremendous contributions to economics and politics. But it was heliocentrism that started the scientific revolution. Now, following in the wake of Copernicus came numerous other astronomers, including the Danish nobleman and astronomer Tycho Brahe. The moon's Great Red Crater that you see down in the southern hemisphere is actually named for him. You can't miss it, and it's featured in 2001: A Space Odyssey. That's where they found the monolith on the moon. Brahe rejected heliocentrism and proposed and said what he called the Tychonic system, in which the moon revolves around the earth and the planets around the sun, but the sun revolves around the earth. Now, he did not work with a telescope, and had he had one, he may not have come up with that belief and the theory. But he did develop a series of more refined and larger sextants and quadrants to observe the heavens directly. Now, as you know by now, I like to put a little side note in all my lessons. Tycho, who you see there, lost part of his nose in a sword fight after getting into a drunken argument over who was the best astronomer and mathematician with another mathematician. He lost part of his nose, as I said. He had to wear an artificial nose the rest of his life. Now, Tycho's assistant, Johannes Kepler, was both an astronomer and an astrologer, and it was he who invented an improved version of the refracting telescope. That's the telescope with two lenses at either end. It's more or less a spyglass that is used on ships. But he contributed his own genius to the scientific revolution by proposing what are known as the three laws of planetary motion. The three laws of planetary motion are as follows. Planets travel in ellipses, not in perfect circles. They travel in ovals. Secondly, planets travel faster when they are closer to the sun, and then therefore slower when they are further away from the sun. And third, planets farther from the sun travel slower than planets closer to the sun. So Earth is faster than Mars, but Venus is faster than the Earth, and Mercury is faster than them all. This is really the start of the scientific revolution, with Copernicus's heliocentrism and Kepler's laws of planetary motion. Here is an illustration of Kepler's three laws with two planetary orbits. The orbits, as you see, are ellipses with focal points F1 and F2 for the first planet and F1 and F3 for the second planet. The Sun is placed in focal point F1. The two shaded sectors, A1 and A2, have the same surface area, and the time for planet 1 to cover segment A1 is equal to the time to cover segment A2. The total orbit times for planet 1 and planet 2 are also figured out here. And this is about as much of geometry and astronomy and mathematics that I want to get into, because that's just not my forte. But some of you who are in the maths and sciences might find this rather interesting. Of course, the most notable astronomer of the day was the man from Florence, Galileo de Vincenzo Buonaiuti de Galilei. Well, we just call him Galileo, who has been, of course, immortalized in the song Bohemian Rhapsody. The Italian astronomer was a polymath himself. He originally thought about going into the priesthood, but his father talked him out of that and said he had great things to do in science and math, and so he enrolled at the University of Pisa. And there he began to experiment with gravity using falling objects from, you guessed it, the Leaning Tower of Pisa. He was the first to look at the planets and the moon through a telescope. He observed the phases of Venus. He then observed and named the four moons of Jupiter, Io, Europa, Ganymede, and Callisto. And then he had the absolute temerity to question whether the heavens were perfect. And for this, the holy office of the Congregation for the Doctrine of the Faith, better known as the Inquisition, came a calling for him and claimed that he was trying to rewrite the Bible. In February 1616, an inquisitorial commission declared that the theory of heliocentrism was a foolish and absurd in philosophy and formally heretical, since it explicitly contradicts in many places the sense of Holy Scripture, and banned his books on the subject. What we now understand, looking back, is that the church did not disbelieve Galileo. They simply found that his theories were so revolutionary that the populace may not have been able to handle that. And so they were trying to put the, hey, hold on, wait up, don't publish this just yet. But Galileo was on the mission. Well, interestingly enough, the Vatican kind of forgot about their ban on Galileo up until the late 1900s, 1990s to be exact, and finally were able to bring it forward. Now, for Galileo himself, 15 years later, he decided to start publishing again, and he was once again brought before the Inquisition, and this time on pain of torture. He was forced to recant his theory by the Inquisition and say that the earth does not move, it is the center of the universe and the sun revolves around it, although he allegedly muttered the rebellious phrase, se muove, and yet it moves. He then spent the rest of his life under house arrest. But the genie was already out of the bottle. The works had been published. You can't burn every book. You can't put every book in a enclosed safe. Somebody's got a copy of it somewhere. And eventually his works were smuggled out of Italy and published in the Dutch Republic, because the Dutch Republic will always be the Dutch Republic. On the left is the tomb of Galileo in the Church of Santa Croce in Florence. As is always the case, Galileo's first tomb was put into a really obscure area because the church did not want him to have a prominent grave, but then they moved him into Santa Croce. Well, when they did that, people began to cut off parts of his body, including his fingers. And so this is the middle finger of Galileo's right hand. that's on display, almost as if he's, I don't know, making a little gesture toward the church. The scientific revolution continued in medicine now. And in the right-hand corner, you see Philippus Aureolus Theophrastus Bombastus von Hohenheim. We simply refer to him as Paracelsus, who was a German-Swiss physician who experimented with new drugs. He actually reintroduced opium as a drug and started to experiment with opiates. He also developed liniments, like Bengay is a direct result of Paracelsus's own work. And he also begins to engage in surgery. See, in those days, doctors did not actually cut into bodies. That was the job of a barber. The doctor would direct the barber into doing some minor surgical procedures. Paracelsus now writes his great book, Der großen Wunderärzte, and he lays the foundation in it for modern pharmacology and toxicology. Now, following in his footsteps is Andreas von Wessel, also called Vesalius, Andreas Vesalius. Now, he was a Flemish physician. That means he comes from Belgium. He's a French-speaking Belgian. And he worked in dissection. He actually begins to dissect the bodies himself. And in doing so, he overturned the theories of Galen, which was the classical physician whose works people simply relied on. There was no experimentation during this time. You simply pulled out Galen and said, what did Galen say? And then they followed it. Well, Vesalius says, to hell with Galen. And Vesalius, in the process, becomes the father of modern human anatomy. So all you pre-med students out there can think of Vesalius when you start your first class of gross anatomy in med school. His book, De Humani Corporis Fabrica, revolutionized anatomy. It was a direct result of the detailed painting that emerged from the Renaissance. The Renaissance painters didn't just paint on walls and churches and cathedrals and palaces and so forth. Painting became a form of almost photography. Now, the other great breakthrough in medicine was accomplished by William Harvey, who was an English physician who served King James I and then Charles I and survived serving the king during that time. Now, Harvey examined the circulatory system, and he came to the conclusion that the heart was the pump of the blood, and the blood flowed through the various organs of the body. Up to this point, people thought that blood just simply sat in your body and that the pressure was just simply that, pressure in your body. It was not a result of pumping. He also managed to start casting doubt on the efficacy of witchcraft trials, did not use empirical evidence all that much. Again, as with Copernicus, he was not the first one to posit any theories of circulation. This had been proposed by the Greeks many centuries before. But you see, the attitude of many during these times and the instruments and processes that they engendered gave impetus to him pushing this theory on the public. This is a time of great contradiction, of challenging. That's what the war had done in many ways. This is what the timing of the age has done. Many people are simply questioning. And perhaps the epitome of this movement was the development of the scientific method. And that was the product of our friend René Descartes. Not Descartes, but Descartes, who had been the military observer early in his career at the Battle of White Mountain. Descartes was a French mathematician and a philosopher who worked most of his life in the Dutch Republic. Descartes formulated the scientific method of experimentation and also allowed for algebra and geometry, two of my hated subjects, to be linked together. The scientific method is what we follow to this day. Propose a theory, conduct experiments to either prove or disprove the theory, and then come up with a reasonable conclusion. Descartes is called the father of modern philosophy. He's the father of modern mathematics. We have Cartesian coordinates in geometry and algebra and so forth. His signature philosophical statement is cogito ergo sum, or I think, therefore I am. However, he was a Frenchman, and so Descartes would have said, je pense donc je suis. Now, with the scientific method now in full bloom, many latched onto this process and developed it further. People like Sir Francis Bacon. Francis Bacon was an English polymath who served as Attorney General and as Lord Chancellor of England, so he is a politician. He developed the first library system of classification. He probably died of pneumonia while trying to examine how freezing would help with meat preservation. He broke with tradition by attacking blind reliance on ancient writers. He said, don't just simply go to Galen's book. Think for yourself, damn it. And Bacon's contribution is found in the beginning of inductive reasoning. That is, the premises are viewed as supplying some evidence, but not full assurance of the truth of the conclusion. In other words, it's a probability. Inductive reasoning is distinct from deductive reasoning. If the premises are correct, the conclusion of a deductive argument is certain. In contrast, the truth of the conclusion of an inductive argument is probable based on the evidence given. And what all this amounts to is the theory of empiricism. That is, knowledge that comes only or primarily from sensory experience. For instance, that pan is hot. I don't take your word for it. I'm going to put my hand on it. Oh, yes, it is hot. That's empiricism. It's very simple when you think about it. We obtain knowledge by observing, listening, feeling, tasting, smelling, seeing. Empirical research, including experiments and validated measurement tools, guides the scientific method. But the medieval period was not that far in the past, and some of the old ways of seeing the world lingered or never were quite put to rest, and many would argue, even to this day, they've not been quite put to rest. Magic still permeated numerous levels of society, and science often went up against magic, because there was still not a very clear division between science and magic. After all, I've just pointed out that several astronomers also served as astrologers. Well, what happens as a result of this in this period where magic and science go head to head, you get witchcraft trials. Now, witchcraft trials had kind of declined quite a bit since the Middle Ages came to an end and the Renaissance had begun. But then comes the 30 Years' War, and the devastation and the fear and the anxiety that the 30 Years' War engendered in people now begins to break out again in witchcraft trials because people felt that the end times were near and or Old Scratch, the devil, is out and about doing his mischief. And nowhere did anxiety and fear reign than in the devastated lands of South and Western Germany, that is the Holy Roman Empire. For instance, in one town, Bamberg, the witch trials of the 17th century claimed about 1,000 victims. It reached a climax between the years 1626 and 1631 under the rule of Prince Bishop Johann Georg Fuchs von Dornheim. The famous Drudenhaus witch prison that you see in the drawing in the upper right, built in 1627, housed more than 300 people suspected of witchcraft at any one time. It's not standing today, but there are detailed accounts that still remain. Witchcraft trials are often a sign of social stress and anxiety. Now think about it. I'm not trying to make a political statement here, but remember that when Barack Obama was elected president of the United States in 2008, the very fact that a black man was elected to the presidency led many people to believe that the end times were near.
It was social stress. There was anxiety. The same thing could be said for the occupant of the White House from 2017 to 2021. That brought a lot of social stress and anxiety. During this particular time, witchcraft trials were often directed against women. And many times it was women who were of ability, who may have been a little more outspoken, who may have held a little bit more property than men felt that they deserved to hold. Oftentimes, too, witchcraft trials or periods of witch scares are linked to religious reform movements. That once the witchcraft trials sort of peter away, people kind of look sheepishly at themselves and they start to say, well, maybe it's not the devil out there, it's the devil within. Maybe I need to start thinking about myself and God and so forth. Now, for instance, you'll come, if you study U.S. history, you'll come to the Salem witch trials. And the Salem witch trials was, America's great moment of insanity. What follows that, though, is a movement called the Great Awakening, in which people begin to start focusing in on their own souls and the devil working on that rather than on everybody else's souls. In addition, the unclear line between science and magic also begins a major shift in religious, scientific, political, and philosophical attitudes that would culminate in a movement that would reshape the very collective consciousness of Europe.